Hi everybody, and welcome to the Raspberry Pi for the older generation. Well, hi everyone, and welcome back to another video. Hope you're enjoying these videos. Hope you're all learning something. Now remember, I know it's called Raspberry Pi for the older generation, but I don't mean the seniors. I'm talking about anyone that's got children to grandchildren at school, so we can communicate with them. Now, as you know, we're working through the modules. We're working through the modules at the moment, and then we're going to go on to projects. Our next module, let me just go to this scene. We're going to be looking at the LCD 1602 display screen. Okay, so that's what we're going to be looking at next. All right, now there's two types. There's two types you can get. The older type, the above one, has 16 pins because the LCD screen is 2 rows, 16 columns. All right, and in the old days you used to have to plug a cable to every one of these pins. Well, now the new module of the I2c LCD 1602 module has a PCF 8574 chip on the back. Let me see if we can show you that. Right, so this is the screen. This is the screen. Okay, and if we look on the back, we got this PCF 8574. It's this here. All right, chip. Right. So instead of having 16 cables, we now only have to have four cables. Right. Now, before we can start configuring this, let's go back to this. Before we start configuring this module, we have to download some libraries. Now, there's two libraries we have to install. Okay, that's the library for the PCF 8574 and let's go find the right page, and the Adafruit _ LCD 1602. Okay, so they're the two libraries that we have to install. Now, I have left a link below in the description for the libraries, so so it's easy for you to find. Now, there is a rule that, let me open my file, wherever you save the code that we're going to be writing today, you have to have those two libraries in the same folder. Right? Have to be in the same folder. So when you've downloaded them, save them to the same folder you're going to write this code that we're going to be writing shortly. So as you can see here, I've got the Adafruit library, and I've got the PCF 8574 library. Right? Right. Now, it's also important that you name our new code correctly. So I'm going to go new. Right? I'm going to go file, save as. Right? I'm going to put this in, and you need to read it. It's capital I to capital C L C D 1602.py. Right? So that's what you need to name this file. Right? Before we could name it whatever we want, but because we're using libraries, it's got to be named correctly. Right? So we'll okay that. Right, so there's our new file named. On this occasion, we don't use our template because the code is completely different. All right, the code is completely different. Now, just to show you that. Okay, now we'll move on and we'll go to installing or connecting the display. Now, on the display, if you have a look, I think you can just see it in there is all of the connections. They're all listed, right? And we're going to go to the connection on here, on the board. Now, let me just show you the whiteboard. Now, remember that on the whiteboard we had some reserved pins, So if you look at pins 3 and 5, the light blue ones, you got I2c1 SDA and I2c1 SCL. They're reserved pins, okay, and they are reserved for the 1602 display. All right, they are for the 1602 display. Right, so let's go back and let's cable her up. We need 4 cables. All right, and I'm using a red one. 4. We've got it like that. Okay. Sorry, like that. Got it like that. Turn it over. And we go to the first pin here, the red pin. All right, I need to get my, where you can see that, okay? The red pin, which is SCL, right? SCL, and it needs to go to the SCL, which is the first pin on here. So the first pin to SCL, the top pin. Okay, the next colour we need is yellow, and that goes to there. Let me just do it, then I'll show you it. Okay, oh, can you see that? Yeah, and that goes to SDA, and that goes to the next one, SDA, on our connector. Right, next we need, I'm going to use a green, yeah, green, which is the next one along, which it goes to this module, goes there, 5 volts, okay, so we go to the 5 volts, and our final one, I'm going to use like orangey brown, goes to the ground. All right, so, and that goes to the ground. You can see how it comes on. So let me just show you it again. First one, the red one, goes to SCL. Yellow one goes to SDA. Green one goes to the 5 volts. And the yellowy brown one goes to ground. Now, on the back, we got this little adjuster. This adjusts the brightness. So if I get me screw in, where you can see it, if I turn it up and down, you can just see it changing. All right. So, if you don't get any characters, coming up on the screen, you need to adjust that screw. Right, so let's just put it here for now, where we can all see it. Ish. Ish. When we come to show the excuse me, show the display, I'll sort it out. Right, okay. So what we're going to do now is come down to the code. Make sure I'm in the right place. Okay, the Python code. Right, let's open Thony as we've already saved the file. Okay, let's start. So we're starting from raw, no template. So the first command is from PCF. Okay, 8574. Import PCF capitals 8574 underscore capitals GPIO. All right, so basically, remember we normally use the board command. We're using the PCF 8574 library for our GPIOs. All right, from Adafruit, capital A, right, underscore, capitals LCD 1602, import, space import, Adafruit, underscore, char, capital C on the char. Char means character. LCD. Right? Get that out of the way. So far, so good. Then, come down a couple. From time, import, sleep, comma, space STRFTIME, shift time. Right, from date time. Yeah, from date time, import date time. Oh, see Kate time, date time. All right. Now what we are going to be doing is showing the temperature and system time of our Raspberry Pi on the 1602 display. All right. So that's date time. Let's move on. Define. Okay. Space. Let me just mark where I am. Get. Underscore. CPU. Underscore. Temp. So this code that we're going to write now is going to get the temperature from our system. All right. Back colons return. Temp space equals open. Okay. Brackets on. Exclamation, not exclamation, quotes, / system, SYS, / class, forward slash thermal forward slash thermal underscore zone 0 forward slash temp. Quotes. Oh, quotes. Oh dear. Quotes off. All right. Brackets off. Close that bracket off. Got that so far? Looks okay to me. CPU space equals TEMP dot read. Brackets on, brackets off. Okay. Then we have a TMP for temperature dot close. Brackets on, brackets off. All right. So remember, this is giving us the temperature, the code for the temperature. Then return space. And here it's got quotes. Right, squiggly brackets. All right. That is shift and the key next to the P for me on my English keyboard. All right. Squiggly brackets. Colons of full stop 2F squiggly brackets off. Dot format brackets on. We want it as a float. All right, we want it as a floating number. Okay, not a is it integer? But we want floating numbers, so we can have the 1 point, etc. 1 point. All right, brackets on. CPU, brackets off, forward slash 1000, brackets off, plus exclamation mark, C capital, that's another exclamation mark. All right, so let me see this exclamation mark. I've just seen I've missed an exclamation mark before the dot float. There's another exclamation mark in that. It's good when it lights up green like that, because then you can see you've made a mistake. Right, you've made a mistake. Return. Sorry, enter. Right, and enter again. So our next line of code, we're going to get the system time. All right, so define get underscore time underscore now. Brackets on, brackets off, colons. Auto indent. Return date time dot now. Right, brackets on, brackets off, dot, remember this, STRFTIME, brackets on, quotes, sorry, quotes. It looks like about 3 spaces. I'll put in 3. So we want percent, capital H, colons, percent, capital M, colons, percent, capital S. All right, and then it's quotes off, and brackets off. So that's our hour, minutes and seconds. All right, percent H, percent H, colons, percent M, colons, percent S, quotes off, brackets off. All right. Let's go now to our loop. Okay, we're now going to go to our loop. Def, loop, brackets on, brackets off, colons, return, auto indent. MCP dot output, right, brackets on, a 3, 1, a brackets off. This turns on the backlight of the LCD screen, okay? Turns on the LCD backlight, all right? LCD dot begin, brackets on, 16, 2, brackets off. That sets up our rows and our columns. Remember, we've got 16 rows, 2 columns. Radio? Radio. Okay. While true, brackets on, true, brackets off, colons. All right. While true, true is always true. This is going to clear the LCD. All right. LCD dot set, capital C, cursor. All right. So we're going to set it right at the beginning. All right. So it's brackets on, 0, 0, brackets off. So that's going to set the cursor position right at the beginning of the display. Okay. Enter. Then LCD dot message, brackets on, quotes on, CPU capitals, space, quotes off, plus get underscore CPU underscore temp, right, brackets on, brackets off, plus quotes, backslash, backslash here, yeah, backslash n, quotes off, brackets off, display CPU temperature. Let's move things down a bit so you can see. Right. So we've done the temperature. Let's come down a bit. Right. Next, it's LCD dot message, brackets on, get underscore time underscore now, brackets on, brackets off, space, brackets off. Display the time. Right. And then it's sleep, brackets on 1, brackets off. Okay. So Come down. We're going to go to our destroy. Okay. So, yeah. Def. Define. Destroy. Okay. Would be as bad if I could spell. Define. Destroy. Brackets on, brackets off. Colons. Enter. LED. Dot clear. Brackets on, brackets off. Enter. Enter. Time dot sleep. OCD, OCD. While true. 20. Right. Okay. Right, no problem. Just need to put a space in here. Right. Come down. Come down. Let's come down. Come down. So. Back to the beginning. Right. PCF 8574 underscore address equals 0 times 27. I2c address of the PCF 8574 is on 27. All right. And then if we go to our next line, PCF 8574 A capital underscore address equals 0 times 3 capitals. This is the I2c address for the PCF 8574A chip. Okay, and now we're going to create a PCF 8574 GPIO adapter. Right, so come down. Let's move down a bit so you can see. Try to make it as easy. Try colons return MCP space equals space PCF 8574 underscore GPIO capitals brackets on PCF capitals 8574 underscore address brackets off. Right, brackets off, return, backspace. All right, except all right, colons, return, auto indent, try, colons, enter, auto indent, MCP equals space PCF 8574 underscore GPIO capitals brackets on, PCF 8574, capital A on the end of that, underscore, address, and brackets off. Right, enter. Okay, so that's our first accept try. Backspace under the try. We want another accept. Colons, return, auto indent, print. Space, brackets on, exclamation mark. I, capital, to C, capital. Capital A for address, space, error. Capital E on the error, space, exclamation mark, quotes, brackets off. And exit, brackets on, 1, brackets off. Yeah? Boom. Backspace to the beginning. I'm on line 42. LCD. Space equals space. Adder fruit. Capital A on the adder fruit, underscore. Char for character, capital C. LCD capitals, right? A bracket on. Okay, pin, underscore. I want to get this right. RS equals 0, comma, space, pin, underscore, E equals 2, comma, space. Now next one is pins with an S, underscore, DB equals, now this is square brackets, 4, comma, 5, comma, 6, comma, 7. Square brackets off. Comma. GPIO capitals equals MCP, brackets off. All right. Bosh, bosh. All right. So that's so far. Nearly there, nearly there. Now, what I like to do is save typing this all out. I like to just open any one of our programs. This last bit I like to copy, so much quicker. And paste. So much quicker doing it that way. All right, just come, or you can get it from the template, whatever. All right. Okay, so that's our end. Right, let's save it. Okay, we've saved that program. And close this one down. All right. So. Right, yeah. Looks okay to me. The only thing we can do is run it. See what issues we got. Okay. I-42. 42. LCD equals Adafruit underscore char LCD. Pin. There we go. Seen it already. RS. Control C this, get out the program, let's save it. And let's try again. Still line 42. So RS equals 0, a comma. Pin underscore E equals 2, comma. Pins underscore DB equals square brackets 4, 5, 6, 7. GPIO equals MCP. Right, let's just check this. Right, let me see. LCD equals Adafruit underscore char LCD pin RS. Boom, 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 boom. 4, 5, 6, 7, comma. That might be our mistake. That might be our mistake. It's a comma instead of a full stop. Okay? It's a comma instead of a full stop. Right, let's do a couple of Control C's. Let me save that. And let's run the program again. Fingers crossed. Fingers crossed, everybody. There we go. There we go. Let me have a look. Okay. Let's go to overhead. There we go. Let me see if you can see this. Hopefully you'll be able to see this. Can you see it? No, let me just get my screwdriver on here. Hold that. If you can see it. Too bright. Can you just see that? No, too low. I think you can just see that. I can just see it. So there you go. We've got our temperature, CPU temperature, 3262.62, and it's 12:51. 12:51. So there we go. There we go. We got it going. We got it going. Okay. Right, just a small mistake there. Just a small mistake. Hope you enjoyed the video. I enjoy making them. I hope you're enjoying these videos because I think we're all learning together. We'll carry on in the next video with some more modules, components, and then once the components are finished, as I said before, we'll move on to some projects. All right. So again, thanks for watching. Please give us a thumbs up. Please comment below. And please don't forget to subscribe. Don't forget to subscribe. And I'll see you in the next video. Bye bye.